Alright, so continuing on, we're going to take a look at the mean value theorem. So just after Rolle's theorem, you're just going to write down the mean value theorem. And what the mean value theorem says is really exactly like the Rolle's theorem with the exception of one thing. If f is continuous on the closed interval AB and also differentiable on that open interval AB, then there exists a number C in AB such that, this is a listening check, put one box around the word continuous and the word differentiable, just one box around both those words. The derivative of the tangent line is equal to the derivative of the secant line. No, we don't have to find, or rather f of A does not have to equal f of B to use the mean value theorem. Okay, so it has to be continuous and differentiable just like the Rolle's theorem, but f of A does not have to equal f of B. So what does this look like graphically? Alright, so let's say you have 2 points like this and some curve. Let's label it A and B. What the mean value theorem is saying is, again, it has to be continuous and differentiable, meaning continuous, there are no breaks, differentiable, meaning there are no jumps, undefined places, and so forth. So what it is saying is that the slope of the secant line, the slope between the two endpoints, which is a change in y over the change in x, and notice the change in y is fb minus fa, and the change in x is b minus a. So that's the slope of the secant line. Alright, so the slope between the two endpoints is the slope of the secant line. Alright, so it says, the MVT says the slope of that secant line, which is change in y over change in x, which is equal to f of b minus f of a over b minus a, right, is equal to the derivative at point C. So remember, derivative is what? The slope of the tangent line, right? So the slope of the tangent line at point C. So that slope right there. So the slope of the secant line and the slope of the tangent line are parallel to one another. So if two slopes are equal, then they're parallel to one another. Okay, so that's basically what the mean value theorem is saying, is that the two slopes are equal, they are parallel to one another. Now we need another page because we're out of space, so I'm just going to cut along the same line. So I'm not making another tab, I'm just making another page with that same tab. Alright, so looking at an example, let's say we had this question, determine whether the MVT, which stands for the mean value theorem, can be applied to f on the closed interval AB and if it can be applied, find all the values of C in the open interval AB. This is a listening check. Go ahead and color in MVT. Color in MVT in that first sentence. Such that the derivative of the tangent line is equal to the derivative of the secant line. So the function that we're looking at is going to be f of x equals x parentheses x squared minus x minus 2 close parentheses in the interval -1, 1. Distribute the x inside the parentheses so it's easier. So it's going to give you x cubed minus x squared minus 2x. And then remember, it has to be continuous and differentiable, which it is because it's a polynomial, so I'm not worried about that. So once it's continuous and differentiable, the very first thing you have to do is we need to find the slope of the secant and the slope of the tangent. So let's start with the slope of the secant. So step 1, find f of a and f of b, because I want to find the change in y. So f of a, so I'm going to label my interval AB, so f of -1, and you're going to plug in -1 into the equation. So you're going to get -1 cubed, which is -1, -1 squared is +1 times the negative is -1, and then that's going to be +2, so that's going to give me 0. And then find f of b, so now you're plugging in 1 where you see x, so that's going to be 1 minus 1 minus 2, so that's going to be 0, -2. Alright, so that's the change in, that's the 2y coordinates. Alright, so finding the slope of the secant, so number 2 would be plug it into the slope formula, which is change in y over change in x. In other words, f of b minus f of a over b minus a. So f of b is -2 minus f of a, which is 0, over b, which is 1, minus -1, which is a. So that's going to give me negative 2 over positive 2, which is going to give me negative 1. Alright, so the slope of the secant line is negative 1. So that's the right-hand side of the equation. Now we need to find the slope of the tangent line. So number 3, find the derivative of your function. So finding the derivative of the function, that's pretty easy. That's going to be 3x squared minus 2x minus 2. That's the derivative of the function. Okay. Step 4 is going to be now set those equal to one another, because we said the MVT theorem says that the slope of the secant is equal to the slope of the tangent. And I keep saying it because you have to remember it. Alright, so set those equal to each other. And we're just going to solve. So I'm going to take the negative 1 to the other side actually. So I'm going to get 3x squared minus 2x. Negative 2 plus 1 is negative 1. And then that's just a factoring issue. So go ahead and factor it out. I'm going to use a box, but again, if you don't know how to use a box, then just go ahead and do the quadratic formula. So you're going to solve and find your C values. So factoring it out, I'm going to draw a 2 by 2 box. I need two numbers that multiply to negative 3 and add to negative 2. And that's going to be negative 3 and positive 1. The listening check, circle step 5. First term in the first box, last term in the last box, and the two middle terms with the variable. Greatest common factor is going to be 3x. And then that's going to be x, and that's going to be 1. And that has to be negative 1. Alright, so it factors out 3x plus 1, x minus 1 equals 0. Solving for x, I'm going to get x equals, so take the 1 to the side, negative 1/3 and positive 1. Alright, so those are my x values. Now you have to check to make sure that they're in the interval so that you can find your c values, because remember, it is only in the interval. So check the interval to make sure that your answers are in the interval. And this step is actually very important for both the mean value theorem and the Rolle's value. Always check your answer to make sure it's in the interval. So the interval we're looking at right now is negative 1, 1. Alright, so looking at these two answers, okay, the question was that it's in the open interval. So it has to be in the open interval. So that means that 1 is not in the open interval. So the only answer that it could be is negative 1/3. Again, that 1 is not in the open interval that in the question that we asked. So again, there's an actual direct correlation between mean value theorem and Rolle's theorem. I'm actually going to do that in another video. So stay tuned and let's practice.